Hi there. Thanks for joining us again. This is Space Nuts, where we talk astronomy and space science. My name is Andrew Dunkley. Coming up on this episode, we'll be looking at, or more to the point, listening in on the Boeing Starliner. The reports are that strange noises are coming from inside and nobody's in there. So what could it be? We'll also be taking a look at the history of Ganymede. It apparently took a hit by an asteroid that was bigger than the one that killed off the dinosaurs on Earth. We will be revisiting the story about black hole jets. They think they've figured something out. And believing in aliens. Do you believe in aliens? Well, if you do, you might want to listen in on this story because some are saying this is becoming a problem. This is all coming up on the next edition right now of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And he's back again for more. It is Professor Fred Watson, astronomer at large. Hello, Fred.
Hello, Andrew. I'm here for more, but I'll give less, just, to be contrary.
Yeah, less is more, though, Fred, as we know.
Yes, indeed. Yes, indeed.
I've heard that saying a few times over the years, and it's not true in golf. So less is not more, unless you're playing a Stableford.
Oh, Stableford.
A Stableford, which was named after a man named Stableford, believe it or not.
Perfect. And what is it?
Yeah. It's where you get points rather than you get points for what you score. So you always score. You get 2 points for a par, 3 for a birdie, 4 for an eagle, 5 for an albatross, which no one ever gets. Or you only get 1 point for a bogey and nothing for anything worse than that. But there are variations of it, but that's the one we play.
And so less is less. Yes, you're right.
Less is less. Yes, exactly right. Or if you hit it less, you get more. So it can go that way too. It's a weird game.
It is a strange game, is golf.
Golf's a game of opposites. You hit down to get the ball up. You hit left to go right. You swing right to go left. It's, no wonder no one can play the damn game.
And when you get to the end and you should feel glum, you feel happy.
Yeah, that doesn't happen. You generally feel glum.
Yeah. That's what I thought.
Can we talk about the Boeing Starliner, because it's in the news at the moment. I know we're sort of recording a little bit ahead of time, so the story may well have changed by the time this comes out. But the Boeing Starliner, as you know, is kind of stranded, and the astronauts are stuck on the International Space Station, from what I've heard, until about February. They're trying to figure out how to bring the Starliner back. There's been talk of sending it back empty. In the meantime, Fred, there's been some weird noises coming from inside. You obviously heard about this too, because we both thought we should talk about it. Yeah. I have got a recording that was provided by NASA, which is a conversation between Mission Control and astronaut Butch Wilmore. And I'll let it sort of pan itself out before we discuss what the probable noise is.
There's a strange noise coming through the speaker, and I didn't know if you could connect into the Starliner and let me keep mic and let you hear. I don't know what's making it, but I don't know if it's something that maybe is connected between here and there, making that happen. But anyway, can you do that?
We can configure that, Butch. Give us a minute, and I'll call you back when it's ready. All right, Butch, that one came through. It was kind of like a pulsing noise, almost like a sonar ping.
Yeah, I'll do it one more time, and I'll let y'all scratch your heads and see if you can figure out what's going on. Here we go.
Yeah, so that was astronaut Butch Wilmore on the International Space Station conveying his concerns, or at least asking NASA to investigate this odd noise coming from inside the Starliner. And they've been trying to figure out what it is. Now, I know the answer now, but when I first heard it, I hadn't read the story. And my immediate thought was audio feedback. That's exactly what I thought it was. And that's what they believe it might be, a feedback loop.
Yeah. Well, you listen to audio all the time. You've probably been in many studios where there's feedback that you don't want, and it always sounds like that.
It does. In fact, when I worked for the ABC, if you didn't push the magic button before you went on air, the satellite fed back through all the transmitters. So everybody who was listening would got that sound, almost exactly like that.
Yeah.
So, yes, you got a call very quickly from Master Control in Sydney if you didn't push the orange button. It was the green-orange button too, because it was actually marked orange because that's where the line went from Dubbo to a city called Orange, just down the road.
Okay.
And so they had orange written on the button, but the button was green, so we affectionately called it the green-orange button.
Yeah, well, it would. That's exactly the description. It's the green-orange button. That's right.
But yeah, feedback. Turns out it was probably feedback in the audio systems.
Yeah.
So easily solved, but it must have sounded weird to them, this noise.
They probably did worry for a minute. Who's got into that? You know, is this somebody from outside our vicinity on planet Earth, or what?
Yeah, it certainly sounded like someone trying to get in.
Yeah, yes, it does. Yeah.
Anyway, problem solved. Well, mystery solved. I don't know if they've solved the problem. They certainly haven't solved the problem of the Starliner's issues, but they're working on it.
It will, we believe, by the time this goes to air, I suspect it will be back on Earth. Because there's serious talk of when it will come back. So yeah.
Okay, Fred, let's move on. Ganymede. This is an interesting world. It is it suffered a similar incident to that of Earth so many million years ago when Earth was struck by an asteroid that basically obliterated most of the life on the planet, including the end of the end for the dinosaurs. I think they were already in trouble, but this asteroid finished the job. Well, now they've been looking at the history of Ganymede, Jupiter's largest moon, and it looks like it took a similar hit some time ago. In fact, that asteroid was much, much bigger.
Yes, it would have to be because the modelling that has been done by a group based, if I remember rightly, in Japan, that modelling shows that whatever it was that hit Jupiter's moon Ganymede was enough to tilt it, to change its axis. And that's big stuff. That's big time stuff. You can clout it with something small and it might destroy a biosphere or muck it around like the Chicxulub asteroid did that wiped out the dinosaurs. But to change the way an object rotates, that is really something hefty. And the thinking is that the asteroid that hit Ganymede was probably 20 times the mass of the asteroid that hit our planet and got rid of those naughty dinosaurs back in the day. So, the study comes, it is, in fact, scientists at Kobe University and elsewhere. What they've done is looked at surface features on Ganymede. And in particular, there are what are usually called furrows. They're probably valleys when you get down to the scale of what they look like. We call them furrows, and they're concentric circles. They're not just things that traipse across the disk of Ganymede. They are concentric circles, and their diameters measured in thousands of kilometers. Remember, Ganymede is bigger than the planet Mercury. It's its diameters well over 5,000 kilometers. What these scientists have done is looked at these circles, and in particular looked at kind of where the center is, the center of what's called the furrow system. I suppose you think of furrowed brows and things like that, but that's what they are. And it turns out that center is exactly opposite where Jupiter is in the sky of Ganymede, because like most moons next to a big planet. Ganymede is tidally locked in its dance around the planet Jupiter. It's tidally locked, so it always faces the same side to Jupiter. This is telling you that the center of the furrow system is directly opposite where Jupiter is in the sky. And this has led the scientists to do modeling as to how that could have occurred. And sure enough, something big has hit it. Only a large impact could have moved the rotational axis of Ganymede in the way that we think it has happened. So, really quite significant discovery. Some really very nice planetary geology, if I can call it that, that's gone into this study. And very much an outcome that we think might change our understanding of Ganymede.
Mm. And we're talking about an asteroid that was 300 kilometres in diameter.
Something like that.
Which is
correct,
about 100, about 180 miles in diameter?
Yes. Yeah.
Would be about, That's a big rock.
It is a big rock, yes. We would not, had that hit the Earth, we would have probably had a global extinction of everything because the effect on the planet's atmosphere and biosphere would have been devastating.
And you'd have to say that would be irrecoverable. Life would not have developed at all.
It may have done. But it might have had to start again. From whatever processes started life 3.8 or thereabouts billion years ago. You might be going back to square one, which sort of may have happened anyway. In the earliest history of the planet, because it went through various phases. We talked not very long ago about snowball Earth, which actually wasn't that long ago, 700 million years ago. But in its early history, it probably had all kinds of weird and wonderful phases that it went through.
And how long ago did this happen to Ganymede? 4 billion years ago.
Something like that. That's correct. Yeah. And that's a time when the solar system was pretty wild and woolly. There was still a lot of debris left over from the formation of the planets, like large asteroids, which were swirling around the solar system. It may even have been that Ganymede was only just tethered to the planet Jupiter at that time. It probably may even have been itself a very hot world, because 4 billion years ago, the solar system is only 4.6 or 4.7 billion years old. So you're talking about a very early time in the history of our solar system, and things would have been very different from what they are now.
Yeah. What would have happened to the asteroid? Would it be absorbed into Ganymede, or because it made a crater, like a massive crater, 1,600 kilometres or something in diameter?
Yes, that's right.
Huge.
So you're absolutely right. We think that Ganymede is an ice world, that it has a very thick layer of ice, probably 150 kilometres thick, much thicker than what we think Enceladus has. But of course, Ganymede is much, much larger than Enceladus or Europa. And underneath that layer of ice, there is an ocean, we think. We have very good reason for believing that. And that is probably where the debris lies. It's probably been absorbed into the ice crust of Ganymede.
If we got close enough, as it rotates, we could hear a rattling, scraping sound. That would be
the asteroid churning around underneath the ice layer. I suspect it probably got obliterated, but there should be rocky debris from it, you would think, which might well be something that the first time we send a lander to Ganymede that sort of lands among the furrows, which might be quite hazardous actually, but once you do that, you might very well be able to look for evidence of the devastation of this asteroid, the bits and pieces that are left over from that cataclysmic impact.
I know people are saying, ask the question, Andrew, ask the question. So I'll ask the question. How do we know this happened? How is it just because we're looking at the surface going, oh, hello, what happened here? Or is there something else in play?
No, you're right, absolutely right, because I've skirted over that. So the concentric circles are what tell you that there was an impact event. That's basically the debris or a kind of quasi crater. But it's the position of this in relation to the direction to Jupiter that suggests that the rotation axis of Jupiter has changed, and that's probably because of the way the planet rotates about Jupiter. You expect yes, it's because there's a misalignment of the rotation axis with Jupiter. Even though it's tidally locked, you've got this misalignment. Sorry, I'm trying to find the right words to describe it. So the direction to Jupiter is different from what you'd expect given the rotation axis that Ganymede chose. So when you think about it, the way our moon rotates, it goes around once per lunation, once every time it revolves around the planet. And its rotation axis is almost perpendicular to its orbit, but Ganymede isn't. That's the bottom line.
Okay, right. If you'd asked an Australian scientist what it was, they would have said, "Oh, it's out of whack."
Well, they might also say, "Well, everything's gone bung."
Everything's gone bung. It's out of whack. Yeah. That's what it was.
Yeah.
All right. So, fascinating history and one big collision. Wouldn't you have loved to have been able to film that and put it on Instagram?
You would.
Yes, and you can find that story on Cosmos Magazine's website. This is Space Nuts with Andrew Dunkley and Professor Fred Watson.
0G, and I feel fine.
Space Nuts.
Just going to take some medicine, Fred. So this medicine here.
Hang on. Let me look. Let me see it again. Oh, that's interesting looking medicine. Yeah.
Yes, it is. It's called Molot. No. Could be something similar. All right. Let's move on. And we'll talk now about black hole jets. Now, we've done a story about them only very recently, but it's back in the news. There's more to be told about these black hole jets. And this is something we get questions about so very often, Fred.
We do, because it's kind of counterintuitive. Yeah, you've got a black hole from which, nothing can escape because it's a black hole. And yet it has around it a swirling disk of material, which itself is propelling jets of plasma to the north and south of the black hole. In other words, perpendicular to this disk of material. And we glibly say that's due to the magnetic field of the black hole. Rotating black holes do have magnetic fields. But the details of that, I think, have been, largely theoretical until now, when scientists at the PPPL, which is the Princeton Plasma Physics Laboratory in New Jersey, they've actually done it. They've created a black hole, not quite, but created the plasma that would come from the material surrounding a black hole. So it's a high energy density plasma. They did it by shooting a very, very powerful pulsed laser at a plastic target. So that creates the plasma, and they created basically nuclear fusion in a little fuel capsule, and got from that protons and X-rays, all the stuff that they think would be in this disk of material rotating around a black hole. But what happens is the way the X-rays and the streams of protons interfere with the high energy density plasma, or the way they interact with it, involves very, very strong magnetic fields, which do the sort of thing that magnetic fields do on the sun. They break and recombine. And what they've done is essentially seen how you can create a straight, narrow line of plasma. I'm going to read some comments by one of the researchers, Will Fox, at PPPL. Our experiment was unique because we could directly see the magnetic field changing over time. We could directly observe how the field gets pushed out and responds to the plasma in a type of tug of war. And another comment from one of the other researchers, when we did the experiment and analyzed the data, we discovered we had something big. Observing magneto-Rayleigh-Taylor instabilities arising from the interaction of plasma and magnetic field had long been thought to occur, but had never been directly observed until now. This observation helps to confirm that this instability occurs when expanding plasma meets magnetic fields. So the gobbledygook word there is magneto-Rayleigh-Taylor instability. It's described very nicely by space.com as a bubbling and frothing of the plasma. It sloshes against the magnetic field lines, bubbles and froths, and gives you this instability. It creates shapes in the magnetic field that look like whirls and mushrooms. But this is the tricky bit here, Andrew. As that energy decreases, then like they do on the sun, the magnetic field lines could snap back rather than creating this froth of magnetism. And when they do that, you get a compression of the plasma into this jet of material, just like we see coming from black holes in the centers of galaxies. So an experiment that basically duplicates what happens in the plasma surrounding a black hole. Remarkable stuff. And you need a high-energy physics laboratory to do it. It's not the sort of thing you can do in your backyard.
And we've finally found a good reason to have plastic, which is even better.
To zap it with a 20-joule laser, that's right, yeah.
Yes, we need to do a lot of that. So as I understand it, this has basically opened the door to improve our understanding of what's happening in space in terms of these kinds of events, because it's always been very mysterious, but they've created it in a lab, which is extraordinary on its own. But now it opens the door to wider study and understanding. Is that fairly accurate?
Yeah, that's right. So what they've done, the best modeling that we've got with all the supercomputers doing calculations, theoretical calculations of what you expect to find in the region around a black hole, you can model it till you're blue in the face. But if you can demonstrate it experimentally, and there aren't many circumstances in astronomy where we can do that, because you can't, for example, build planets and watch how they distort the space around them. They're
Not
just
really.
too big. Not really, no. But you can. What you can do with some interactions that involve high energies, and this is clearly one of those, is to build clever experiments. There was some quite nuanced ways in which this experiment was carried out. If you can do that and show that what you get at the end of it is what you expected to get from the theory, then you can be much more confident in applying the theory to a real situation where you've got a black hole in the center of a galaxy. So it's very valuable stuff. And in fact, you can probably learn more from it, because the reality of doing this with your streaming relativistic plasma, that might teach you other things that your theory wasn't sufficiently finely tuned to show. So very valuable experimentation and a great result.
Yes, indeed. If you'd like to read up on that, as Fred said, it's at space.com, or you can read the paper in the journal Physical Review Research. This is Space Nuts. Andrew Dunkley here. Fred Watson there.
Roger, you're loud and clear here also.
Space Nuts.
And we've got one more story, Fred, and this one is going to get people really kind of, maybe divided. There are people in the world that believe that aliens have visited Earth, and there are those that say poppycock. And now they've been looking into these thoughts and claims and beliefs, and it's starting to become a problem. Why so?
Because what it does is it breeds conspiracy theories, because on the one hand, you've got, the Pentagon and others saying nothing to see here, and they're being far more explicit in the way they're saying that now, because we're seeing pictures of what they have seen. But they're seen unidentified anomalous phenomena, but no evidence in any of that these are due to extraterrestrial visitations. So you've got, on the one hand, Pentagon saying that, nothing to see here, and there are large numbers of people saying, well, we don't believe the Pentagon because they're always keeping secrets. So they must be there. So there was a poll done in 2019. This is just one of the statistics that I think is really interesting about this story. A poll done in 2019, a Gallup poll, found that 68% of Americans believe that the US government knows more about UFOs than it is telling. And that's one reason, I think, why there's been much more openness about the Pentagon files about this sort of thing than there has been in the past. We've talked about this before, that there was a congressional hearing not very long ago about these documents. It's really, it's really that idea of conspiracy that is probably the most dangerous thing, because the more people you've got who believe in conspiracies, the fewer people you've got who are, taking a more how can I say, measured line about things that we don't understand. The bottom line is, and I can say this as a semi-working astrophysicist. I don't do much research these days, but I'm still very connected with the field. There is zero evidence of any visitation by aliens to our planet. There is nothing you can present that conclusively proves that. And yet we've got this huge number that thinks that something's going on at Roswell, for example, the government from us. All of that's in the mix.
Oh, there is proof that aliens have not visited Earth, and it's called the Drake equation.
Well, yes, that's right. The Fermi paradox as well. The Fermi paradox says, where are they all? Because we should be seeing them, but they're not here.
Yeah.
So,
I'm just looking at some of the statistics. 24% of Americans say they've seen a UFO. I'm sure it's similar in other countries. Well, you can't absolutely say that people have not seen UFOs. That doesn't mean they're alien spacecraft. It could just be a jet plane that nobody identified, or the sun's hitting it at a strange angle, so it looks like a blob instead of a metal fuselage. There's all sorts of, most of them can be explained away.
That's right. Most of them are the planet Venus, in fact.
Yes, absolutely. Lots of people post questions on social media. Oh, what was that big light in the sky last night? Yeah, it was Venus. Yeah,
exactly. I think sorry, go ahead, Andrew.
I'm just thinking this is not going to go away, because once people get a bee in their bonnet, they don't want to let it go.
That's correct. And there's even a concern that there might be an invasion of the Roswell site, a bit like there was on the Capitol on the 6th of January. That's something that has authorities worried, I think, that could happen. It's also this article, and it's actually it's basically an article from The Conversation. It's written by Tony Milligan, who is a research fellow in the philosophy of ethics at King's College in London. That there is one of the other elements in this article, which is a really interesting one, is the way that in popular ideas, popular conspiracies, a lot of First Nations people are being incorporated into those ideas, that you've got First Nations communities who know a lot more about UFOs and things of that sort than we do. There's a sort of mix in here, and I think that side of it is one that's concerning as well, because First Nations people across the world, including here in Australia, in Canada, in the United States, have got creation stories which are fabulous and wonderful to listen to, and wonderful to align with our understanding of what's going on in the sky and how it works from a scientific point of view.
I think this really started taking off after World War II, but in particular in the 60s and then into the 70s. And there was a really well-made, whether or not it was full of shite or, based on some truths, documentary called Chariots of the Gods. And
yes, that's right. Yep.
I think it busted the whole thing open, to be honest.
The Chariots of the Gods was about the Nazca lines and the Nazca figures. And yes, it's complete fiction, because certainly in the case of the Nazca lines, there's still the pegs that those early Peruvians used to draw them, and bits of string that they used to make the alignments, they're still there. Yeah. And you can carbon date them because they're organic material. That was back in the 60s, you're quite right. It certainly gave us a lot of interest in that thinking. I visited the Nazca lines and talked to people who are archaeologists in that country, specializing in them. There's a good reason why those lines were drawn and why those figures were drawn, gigantic figures in the desert. And that's because they believed that the shamans, the holy men, and they nearly all were men, were able to fly above them and see these things on the ground. That's basically the bottom line why it was. And some of them also mark out what you might call processional tracks. There are things that you could walk along. So there's a hummingbird that is a beautiful thing on the desert floor, which has an entry and an exit. So people could walk along in their whatever their rituals were that they were doing. They followed the path of the hummingbird and came out. So there's a lot of study being done on those lines. But yes, I think Chariots of the Gods kicks it all off in the 60s.
Oh, for sure. Yeah, that hummingbird, I think people who do that walk, they come out just below the back of the wings, behind the legs. That's where the exit is.
Right. I think there is an exit there. Yes, I believe that's right. Yes.
I'm sure there is. But I mean, when you've got presidents and high-profile politicians talking about releasing information about what the Pentagon knows and what the US government knows about these kinds of things, it just stirs the pot, doesn't it? It just goes on and on and on.
Yes, that's right. So the more open you can be, the less likely you are to get conspiracy theories, but there might be, there still might happen whether you're open or not. That's the bottom line.
I think we're way too far down the track for this to be
sounds like it, doesn't it?
Brought under control, to be perfectly honest. Yeah, but it's a fascinating story, really a really good read. You can find that at, now, where was it? Phys.org?
Yeah, it is indeed on phys.org, but it's also on The Conversation. That's where
The Conversation's got a great article on it as well. Check them out. That brings us to the end. Don't forget to visit us online if you so desire and check us out. You can send questions through the AMA link, or you can read the Astronomy Daily newsfeed and sign up for that. You can go to our shop and see what's on offer, all sorts of space nuts, bits and pieces. And you can also support us through the Support Space Nuts button if you would like to do that. And if you do follow us on any social media platforms, please don't forget to like us, follow us, or subscribe, depending on which platform it is. Fred, we're all done. Thank you very much, sir.
It's a pleasure. Always very good to talk about all the stuff that we talk about.
Yes. I'm sure some of these stories will spawn questions. I have no doubt about that, which we'll answer in later episodes. Thanks, Fred. We'll see you soon.
Sounds good. Thank you.
Fred Watson, astronomer at large, and Hugh in the studio, who's been incredibly quiet today. Very, very quiet, which is quite normal. And from me, Andrew Dunkley, thanks for your company. We'll see you on the very next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.